I'm going to do a couple more logarithms using the equivalent statement, and with this one, I don't have the equivalent statement up there, but you have it in the past videos, and I'm sure you've written it down. And what it says is the base to this power equals the argument. And the first thing to do before you begin is to take this 4 and change it to the 1/3 power. It's easier to deal with fractional exponents when you're doing this because you're going to turn it into an exponential equation. So now I think x to the 1/6 equals 4 to the 1/3 equals 4 to the 1/3 power. Now how am I going to solve for this? Well, if I take this to a power that's the reciprocal of this, in other words 1/6, 6 is the reciprocal, an interesting thing happens. I'll have 1/6 to the 6th power. Of course, 6 times 1/6 is 1. X goes to 1, but I have to do that to both sides, don't I? It wouldn't be fair if I didn't do it to both sides. And so I end up with x to the 1, or just x. And over here, I'm sorry, it's 1/3, isn't it? And over here, 6 times 1/3 is 2. 4 squared, which is 16. So x equals 16 right here. I've got one more I'm going to do, and then I want to put up the 3 properties of logarithms and a few other ideas. Okay. I think we'll do 32 out of my notebook here. And if you have the notebook. And 32 is the log base 10. By the way, that's called the common log, and usually they just leave the 10 off, and you assume that it is 10, of 4x minus 4 equals 2. And again, we use the equivalent statement. 10 to the square equals that, so we have 10 squared equals 4x minus 4. We notice we have a linear equation. We have 100 equals 4x minus 4, or 104 equals 4x, or x equals 104 divided by 4 equals x. And I guess 4 goes into 10 twice, 6. 26, that's the answer. When you divide 104 by 4, you get 26. Okay. In the next bunch we're going to need more properties and more ideas to solve them. They get harder as we go along.